Hi! Welcome to this series of tutorials in which we're going to be talking about machine learning using Scikit-learn in Python. As we start, we're going to be doing like a very small introduction of what supervised learning versus unsupervised learning is. And after, we're going to be starting to talk about linear models. And of course, we're going to start with the most classic of all linear models, the regression. Before I forget, in this section, when we talk about the regressions, we're going to be using this book right here, and we're going to be using the Python official documentation, which is here. Okay, so let's get started. First, we're going to define machine learning using a quotation from the book Hands-on Machine Learning with Scikit-learn and TensorFlow. I'm not going to try to pronounce the last name of the author because I can't, and I'm going to butcher it. So we have a picture of how the book looks like, and you can look it up yourself. I completely recommend that book if you want to learn more about it. We're going to be using it as a reference, as I said before, but you always learn better if you read also what they wrote and not only what I'm putting in these tutorials. So what exactly is supervised learning versus unsupervised learning? Supervised learning is when we try to create a model that includes a target variable within the data, the training set that we're feeding into the model. That's pretty much book definition from the Scikit-learn documentation that's available online in the link that's provided in this slide. But what exactly does that mean? That means that if I'm trying to predict whether something's going to happen or not, I'm going to have that y variable as part of my training set. And as the model tries to learn from the data, it's going to use that y variable as reference so that in the future, I can feed into the model only the x variables, and the model is going to make a relatively good job at predicting what's going to happen with the y variable at each of those different observations. On the other hand, for the unsupervised learning, we are not necessarily going to have a target variable that we're trying to predict. We're just trying to find trends within the data that we're feeding into the model. Examples of this include clusters, dimensionality reductions, and even density estimations from the data. Examples for supervised learning include regressions, classification, decision trees, which is a type of classification. All of these different types of models we're going to be covering later, but for now we're going to stick to what are the linear models, and we're going to start with, as said before, what's the linear regression. So Scikit-learn actually offers multiple different models that we are going to be exploring. We're going to start with ordinary least squares, but we also have rich regression, lasso, multitask lasso, elastic net, multitask, elastic net, etc. You can see these two columns that I have here. And the illustration that we have, we're going to be referring it to later. So here we can see that really the regression is the line that best fits the scatter plot, which is basically the image that we have here. And this is the equation for it. So your dependent variable y is going to be equal to the intercept plus the beta times the x variable or the independent variable. I'm pretty sure you have already looked at this equation in your high school or maybe your calculus college course, but what really serves as a refresher are the two equations that appear underneath this equation. So this is the way in which Excel or Python calculates the beta, and underneath that it's the formula for calculating the intercept if you want to look at it more in depth. To our right, I made a point to include the formulas for the total sum of squares, the sum of square residuals, and the sum of squared errors, basically, or the explained sum of square. Sum of squares due to errors, that's why it's SSE, but it also could be called explained sum of squares. And basically, the correlation coefficient is going to be the sum of square residuals over the total sum of squares. In Python, we're going to be using scikit-learn.linearmodel.linearregression, and that's pretty much how we're going to import it into our Python notebook. It's going to be from Scikit-learn import linear models, and from there we're already going to have the estimator object, linear regression, that we can call into in order to create linear regression models. These are the different parameters that the Python documentation provides us with. The first one is whether you want your linear regression to feed an intercept to the data or not. So if I put feed_intercept equals false, my regression is not going to have an intercept. However, if I put true, my the regression model, it's going to feed an intercept into it. The second parameter, it's whether you want your data to be normalized, your x variables to be normalized before you create the regression model. So you can see here in documentation, we have a little explanation of how exactly Python normalizes this data. And for our third parameter, it's in case that you are indeed normalizing the data, it's whether you want Python to create a copy of the original data and then normalize it, or if you want Python to kind of like edit or overwrite the original x variable data set when it's normalizing it. Our fourth parameter is the number of jobs. And after that, we're going to be looking at the attributes, which is basically the coefficients, which you can obtain by writing coef_. And you also have the intercept, which you can obtain by writing intercept_. Right now, we're hitting the limit of the 5 minutes of our video, so I invite you to click on the next one and go with me as we continue exploring linear regression models here with Scikit-learn in Python. Thank you for your time.